Oakley dokley. So now we're going to do limits with the trigonometric functions. Some general trig limits are that if the k is in the domain of a trig function, then the limit as you approach k would just be a valuation of the function at that particular k. A couple A plus limits, which we'll do in class when we're together. If we recall at the beginning of class there, I'll show you why this one holds, and this one's extremely important. So the limit as x approaches 0 of sine x over x. If we were just to replace x with 0, it's 0 over 0, right? So it's one of those do something problems, and this do something always comes out to be 1. And then the limit as x approaches 0 of 1 minus cosine x over x is 0. So our critical stage here is going to be using our trigonometry to simplify things into these forms for the most part. Okay. First problem, limit as x approaches infinity of sine of this expression. I'm going to start introducing some shorthand notation for what's going on now, based on the fact that we've already done the very formal notation in the last two sections, is that as x goes towards infinity, this infinite limit is a rational function with a horizontal asymptote, right? The top and bottom are both linear, so I can tell that the numerator is going towards, this expression inside of the argument of sine is going towards negative pi over 3. So as x goes towards infinity, the argument is going towards negative pi over 3, which means the answer to this problem would be the sine of that argument, negative pi over 3. See, negative pi over 3 is down here in quadrant 4, so its value would be a negative radical 3 over 2. And that's our first answer. Okay, this one is close to looking like that, right? Sine of x over x. It's really important that whatever's in here is the same as what's on the bottom. So I can't quite do this one yet unless I fix it. So I'm going to fix it. I'm going to fix it by putting a 2 there. Because now the top and the bottom, the argument to the sine is the same as the bottom. They're both going towards 0, and they're both going to 0 at the same speed. But you can't just throw a 2 on the bottom of something, because it changes things, unless you also multiply by a 2. So this is like dividing by 2, and this is like multiplying by 2. And what this does is it gives us the advantage that now, thanks to the important trig limit, this goes towards 1, and therefore the result will be 1 times 2, which is 2. Okay, for C, we have sine squared of x. So this becomes the limit as x approaches 0 of sine x, sine x. So we just have strategic rewriting of our objects that we have here. Sine squared of x is sine times sine, and there's one copy of x in the bottom. Because then by the important limit, this goes towards 1. So because the product of the functions, we can just do both limits separately. That one becomes 1, and sine of x, when x goes towards 0, there you can just plug in, and that's unambiguously 0. So 1 times 0 is 0. Okay, now for this one. Okay, limit as x approaches 0 on this one. Let's split it into different pieces. So we have a limit as x approaches 0 of 2 over x minus the limit as x approaches 0 of cosine 3x over x minus the limit as x approaches 0 of cosine of 4x over x. So our special rules didn't have cosine as x approaches 0, and that's because you actually know what these end up being, right? As x approaches 0, cosine of 3x is actually just cosine of 0, and cosine of 0 is just 1. So over here, as you approach 0, you're getting 2 over, 2 over 0. That's either plus or minus infinity, depending on whether you're approaching 0 from the left or from the right, minus, here you'd be getting a 1 over 0, which again would be plus or minus infinity, depending if you're left and right. Oh no, and so is this one, because this would also be a 1 over 0, plus minus infinity. You don't know if you're coming in from the left or the right. So since we don't know if we're coming in from the left or the right, this problem is ambiguous. I can't tell what's going on, so this limit does not exist. I have no nice way of defining it. How about E? Part E says limit as x goes to 0 of tan x over x. Remember, tangent of x is actually, by the quotient identities, sine x over cosine of x. And then there's still this 1 over x on the bottom. Sorry, the x on the bottom, so it's just a 1 over x. So as x approaches 0, let's rewrite this one nice and formally, but in general, we're looking for this. I'm just going to reorder it, because then it's more clear that I'm getting one of those important trig limits of sine x over x, which I know goes towards 1. And so this answer is going to become 1 from here, times 1 over cosine of 0, and cosine of 0 is just 1, and 1 over 1 is 1. So this final answer is just going to be 1. Then for this one, we have the limit as x approaches 0. Again, I'll rewrite this one nicely, but we'll start to shortcut this a little bit as we work more and more problems. I'll put the sine 6x there. I'll put the sine 8x there, right? Sine 6x is on the top, sine 8x is on the bottom. I desperately wish for a 6x down here so I can use the important limit, and I can do that as long as I compensate for it. And I desperately hope for an 8x up here, which I can put as long as I compensate for it. So now what we're getting is a limit as x approaches 0 of sine 6x over 6x. This is the reciprocal of sine 8x over 8x. And this is just x cancels. 6 and 8 can be reduced by 2, so that's a 3/4. So notice now, by important trig limits, this goes towards 1, this goes towards 1, and 1 over 1 is just 1, so all you're left with really is the 3/4. So from now on, I will not do the reciprocal argument here. When something, since the limit as x approaches 0 of sine x over x equals 1, that means its reciprocal will also limit towards 1. So if I get something that looks like the important trig limit but is flipped upside down, I'm just going to know that that's 1 from now on. Okay, some more heavy trig coming up here then. Tangent 3x over sine 7x. Okay, let's rewrite this as limit as x approaches 0 of sine 3x over cosine 3x multiplied by 1 over sine 7x. Okay, instead of the formal rewriting, let's be a little bit less formal, but still get all the pieces in there. So I'm going to put a 3x on the bottom, so that way I can get my special trig limit here, compensating by putting a 3x on the top. I'm going to put a 7x in here, so that way I can match up those arguments, compensate by putting a 7x on the bottom. And then I have my limits. So this is special, going towards 1. This is special, going towards 1. X and x cancel each other out. And so you have a cosine of 3 times 0, and cosine of 0 is 1, 1, 1, and 3/7. And so our net result here is simply 3 over 7. How about for h? For h, we have the limit as x approaches 0. There's the 1/3 thanks to the 3 on the bottom. There's 2 sines on top. And there's 2 x's on the bottom. That's 1. That's 1. And so our net result is 1/3. Okay, let's go see if we start to get some, looks like the next one's going to have maybe some trig identities to play with. Let's go see what we have to do here. Okay. Oh, actually, I might be able to deal with this one okay based on those special identities, those special limits. Let's see. This becomes limit as x approaches 0, sine x I want to put an x on the bottom, so I will, but then I would need to put an x on the top, and this would be the 1 minus the cosine of x. So as x goes towards 0, this part is 1, and this part, this time I will need to do the fact that this is 1 over 1 minus cosine of x over x, because this goes towards 0. So I have 1 times 1 over 0, and remind me, what is 1 over 0? 1 over 0 is undefined, is the potential plus or minus infinity. So we have to do some extra analysis to see what happens. So as x approaches 0 from the left, sine of x is negative, and as you approach 0 from the right, you're positive, whereas cosine is always less than or equal to 1, so this bottom part's always going to be positive. And so if we come in from the left, it's going to be negative infinity, and if we come in from the right, it's going to be positive infinity. And therefore, this limit overall will be a DNE. This one does not exist. Okay, for this one, now our trig identities start in. The cosine of a complement, right, by the cofunction identities is the same as sine of x. So here we have the limit as x goes towards 0. This is the reciprocal of 1, which is 1, and so that's the final answer. How about k? What's going to happen on k here? Okay, let's do... See, the bottom's already a Pythagorean identity. Let's do this. Yeah, let's give it a shot. I'm going to multiply by 1 plus cosine 3x on top and bottom. In other words, the conjugate. So that way on the top I'm getting something that will hopefully turn me into the sines nicely also. So I have a limit as x approaches 0 of 1 minus cosine squared 3x over cosine squared 5x minus 1 multiplied by 1 over 1 plus cosine 3x. Okay, my main reason for doing this is because now I can say that the top is sine squared 3x. My bottom is the opposite of sine squared 5x. And then here we just have a 1 over a 1 plus cosine 3x. Okay, now this is the limit as x approaches 0, negative sign. Sine 3x, sine 3x, sine 5x, sine 5x, and then also the 1 over 1 plus cosine 3x. So I need a 3x and I need a 3x to put in. I need a 5x and a 5x to put in, which I have to compensate for by putting in a... Let's see, that would need 9x squared on top, and it would need a 25x squared on the bottom. So that's what I get for putting in the 3x's and the 5x's. And after this rigmarole, I think we're finally ready now. That's special 1, 1, reciprocal of 1, reciprocal of 1. Of course, if you were to place x with 0, cosine of 0 is 1. So this becomes 1 over 1 plus 1. So I'm getting a negative. This would be a half. And this would be a 9 over 25. And so the final answer appears to be negative 9 over 50. Okay, that one was crazy. And my color, my pen had gotten in the way here. So let's see if I can fit this last one. I'll use a different color to hopefully distinguish. I hope this is clear enough. Let's see. This would end up becoming the limit as x approaches 0 of the tangent of 3x squared over x squared plus the limit as x approaches 0 of sine 5x sine 5x over x So I would need to throw in a 3 here and a 3 here. Technically, remember, the tangent is a sine over a cosine, so I'm already doing a little bit of a shortcut here. I should write out the other one, but I've run out of space, so make sure you change that into a sine over cosine so you can see it clearer. And then over here, I'd have to throw in a 5 and a 5, which means I need another 25. And this is generally going to go towards 1, especially if you change it to sine over cosine, makes that one very clear. This is 1, this is 1, so it looks like we're getting a 3 plus a 25, which is a 28. Okay, so that one did fit, barely, and I skipped a step. Okay, let's do something with a substitution. Okay, substitution here. So let u equal x minus 5. The thing inside of the sign is not what I wished it was. Notice that the limit as x approaches 5 of u is the limit as x approaches 5 of x minus 5, which is 0. So with the substitution, this now becomes the limit as, well, as x goes towards 5, we see that u goes towards 0. Sine of x minus 5, which is u, and that's over x squared minus 25, which is x minus 5 and x plus 5. But our whole setup is in u, so I really should have set these up before. Like x minus 5 is u, and notice that if we were to take the u and add 10 to it, what would you get if we added 10 over here would be x plus 5. So this is really the limit as u goes towards 0, sine u over u times u plus 10. U over u plus 10. So I like to get into the habit of doing all substitutions at one time. So if I was looking ahead and simplifying, I would have done this in the last step. But notice I don't get freaked out by the x plus 5. I just change what my substitutions were and use them to be able to manipulate and turn myself into u. That's convenient now because this is 1. And if you stick u for 0, it becomes a 10 in the denominator. And therefore, this answer is just 1 over 10. How about over here? Let u equal pi over x. Then if we take a limit as x goes towards infinity of u, that would be the limit as x goes towards infinity pi over x. And pi, which is finite, over an infinitely large number is going to get very, very close to 0. So therefore, with the rewriting, this will become the limit. As x goes towards infinity, we see that u tends to 0. Sine of pi over x, which is u, and then pi over x, which is u, and that's our special trig limit, meaning our limit ends up being 1.